Okay, so the last part of today's lecture is Hamiltonian cycles. They are sort of similar to Eulerian circuits in the sense that you have a graph, but instead of visiting all the edges, you want to visit all the vertices. Okay, so you're looking for cycles. Remember, cycle में और circuit में फर्क ये था कि circuits can visit a vertex more than once. A cycle must visit every vertex. Cycle is a path, right? You can't visit a vertex more than once, except for the first and the last vertex. Okay, उसके अलावा you must visit every vertex only once. The question is, does there exist a cycle which visits every vertex in your graph? Okay. Uh, here are two graphs. इस केस में तो मेरे ख्याल में बनाया हुआ है उसने circuit. Okay, so you don't have to visit all the edges in this case. Okay, you only have to visit all the vertices. So for example, if I started this vertex A, let me call it V1, okay, because it will help me. So I go there V2, I come here V3, and I go here V4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20 and 21. Okay, so that's sort of a cycle which covers all the vertices. I didn't miss any vertex, and I did not go to, that's the important part, I did not go to a vertex more than once. Okay, so it means that this graph is Hamiltonian. It contains a Ham cycle. How about this graph? Can you find a Ham cycle in this graph? Okay, let me try to do it. Okay, so let me start it here. 1, 2, 3,
Yes, it can be done.
4. It can be. How?
Here one, leftmost one.
Yeah. Let me label it. Okay, then you can give me the numbers 6, 7, 8, 9, 10, and 11. Okay, go ahead.
5, 6,
5.
yeah, 5, 6,
Okay.
7, 4, 5,
Okay,
6,
6, 7.
3, 2, 1,
6, 7 से कहाँ जाना है आपने?
4,
4.
yes,
Okay.
3, 2, 1,
3, 3, 2, 1,
11, 10, 9, 8,
11,
10, 9.
10, 9, 8. Then what? But you need to come back to 5, right?
You have to come back. And
You need to come back to 5, right? It needs to be a cycle.
then
So I think you can't have a Ham cycle here. Okay, I'm not sure, but I think you can't. Can you guys think of a sort of a property जैसे हमने Eulerian case में हमने कहा था कि if every vertex has even degree, then it must have a Eulerian circuit. Can you think of similar properties for Ham cycles? Something that you can sort of check through an algorithm. Simple. Um, so it
So
turns out there is no such property known. It's sort of an uh, open problem that to find such a property that I give you a graph and you let me know that does it contain a ham cycle or not. Okay, it's a really hard problem. If I give you, for example, a graph on 50 nodes, it will take you probably a lifetime to find out whether this graph contains an ham cycle or not. Okay, so it's that hard. Um, although it looks very similar to the Eulerian problem, okay, but the Eulerian circuit problem is quite easy. I give you a graph, you just check whether the degree of every vertex is um, even or not, okay, and then you just spit out the answer. But the Hamiltonian cycle problem, like I said, it's sort of a problem that probably won't be solved during lifetimes. Even for this moderate sized graphs, okay, a graph on 50 nodes is nothing. The graph on, for example, Facebook people is I don't know, 5 billion nodes or something. Okay, so we have very huge graphs for which this is an interesting problem, but even for very small graphs, it's not known whether how to test whether this graph contains a Hamiltonian cycle or not. Okay, but it's quite easy to describe, right? You should agree that all I want is I want to start at a vertex, go visit every vertex in the graph, and then come back to where I started without going to a vertex twice. But it's much harder. Okay, I'm going to stop here. There are a couple of properties जो आप ग्राफ में चेक करके बता सकते हैं कि ये हैमिल्टोनियन है या नहीं है, but they are not sort of if and only type results. Okay, तो कुछ cases में आप you can look at a graph and you can tell, but in majority of the cases you can't. There is no way to tell whether a graph is Hamiltonian or not. Okay, I'm going to stop here unless there are questions. Okay, that's it, I guess. We'll have our last class 25 on Thursday, and we have an exam on next Monday at exact 2 time. It will start at exact 2. You'll have a exam for 1 hour, 20 minutes. We'll have a 10-minute break, and then we'll start the lecture 26. 26 or 27, okay. Okay, thank you guys. See you on Thursday.